This is the second video on multiple angles for solving trig equations. We have tan 2a equals negative 1.03 where we have a restricted domain and we're working in degrees. So let's start by making a substitution. So let x equals 2a. Another way of looking at that would be a is x over 2. Which we'll use later on. Tan x therefore, so tan x equals negative 1.03. If we find inverse tan of negative 1.03 using our calculator, because we don't have a situation of exact values here, we get negative 45.85 degrees. Time to look at the unit circle. We've got a negative value for tan. Alright, so tan yields a negative value, so we're in quadrant 2 and we're in quadrant 4. So we've got pi take 45.85 degrees. Sorry, what did I say? Pi for? How about 180? Let's be consistent. I've just been doing lots of questions with radians and made a slip up switching to degrees. So 180 take 45.85. Now don't sweat this negative sign. Just think about ASTC as a tip for you there. So that just gives us the magnitude of the acute angle essentially. So don't worry that it's negative. So we get 134.15 degrees. And down here for this one we get 360 take 45.85 and we get 314.14 degrees. So looking at our equations, our generators for the solutions, therefore x is 134.15. Now plus its rotations of 360 degrees, so it'll be 360k because we're working in degrees. We've got the other solution here, 314, so we have 314.14 degrees plus 360k degrees. You've probably seen some others by now using 2k pi. Okay, so the 2 pi has been replaced by the 360 I should say, because we're looking at degrees as opposed to radians. So that's how we'll generate our solutions with those expressions there. K is an integer, of course. So let's generate those, but before we do, we need to substitute back in terms of A, so we're going to use this information here, and so A is x over 2. So we have to divide everything through by 2. Likewise here. Over 2. Okay, and we get 67.25. Sorry, 67.08 plus 180k, and x equals 157.07 plus 180k. And sorry, these are A's. as you know, we sub back in for A. So we have two ways of generating A, and let's look at the solutions. When k equals 0, A is clearly 67.08. And when A is 0, k is 0, A is also 157.07. So when k is 1, we have 67.08 plus 180, 247.08, and 157.07 plus 180, which is 337.07. Okay, now keep an eye out on this one's got a slightly unusual domain, perhaps 90 to 270. So let's have a look here. That one there, that's outside of the domain, so that's not a solution. That one there is outside the domain. It's too large. It's outside the domain. So we've really only got two solutions. We've got that's between 90 and 270, and so is that. We could try k equals 2, see if there's any more, because so far we've only got 2, and interestingly enough b is equal to 2, so if it was sine and cos we'd normally get 4 solutions at this stage. Perhaps there's some more. So we've got a equals 67.08 plus 360, because that's 2, this is when k equals 2, and that comes out too large. Even if you don't even need to calculate it, if you just look at it, 180 times 2 is 360. Our domain only goes up to 270, so if you add something on a 360 it's going to be too large. So that one's also too large. What about our last option here? We've got 157.07 plus 360, for the same reason it's going to be too large as well. So that's it, we've exhausted all possible solutions. If we took 180 off this or this, we would get less than 90, so that wouldn't work either. So that's all we've got. So the solutions are basically this: A equals 247.08 degrees and 157.07 degrees. So it's interesting that there are only 2 solutions there, and as I said in a previous video, this happens sometimes with tan compared to sine and cos.